So remember in the last lesson I had a few moments to check out our studio, and now we can see it's already starting to fill up with lots of different projects as well as some of my own. So keep checking back into our studio, guys, and don't be afraid to like and favorite other people's projects as well if you like what they've done. Because maybe we'll start doing a couple of competitions later on. So if I haven't gotten around to liking yours, guys, it's because there's just been so many that I'm just working my way through them as we go along. Now let's have a look at today's challenge. So today we're going to be creating a backdrop, which is exactly how we were doing for creating a sprite, but we're going to do it for the background of the project or the stage. We're going to be looking at the types of instructions today, so if you're wondering what a for block does or what an if block does, we'll look at all that today. And we're going to be looking at making Pong, which is one of the very first games that was ever made. But we'll make a little spin on it ourselves and we'll do an Angry Bird edition. So I hope everybody's excited for today's lesson. Let's look at the first part, creating a backdrop. So if we want to create an Angry Bird background, and just if you were wondering how I made the Angry Bird, guys, I just did the pixels bit by bit until I had the full Angry Bird made. So the first thing we need to do is create a new backdrop in Scratch. And you can see where the stage is selected here. And all you need to do, if I just grab my pen for 1 second, is just create a new backdrop by painting on the paintbrush here. Then you can use the tools exactly like we did for our sprite drawing. You can use the paintbrush or maybe draw rectangles, and of course use the paint bucket to fill in whichever colors you need. So the first thing you get to do then is draw the ground, I suppose. We'll need, for when the Angry Bird touches the ground, we'll need to be able to say the game is over once he touches the ground. And we'll need to add a sky as well, just to make the background look a little bit more interesting. So maybe something that looks a little bit like this. And don't be afraid to do the same for your project after the lesson. So keep watching with me and we'll have a bit of fun doing it now. So here I have my starter project. Let me just refresh that page. Here we go. And you can see I have my Angry Bird and he's fallen down already, and I have my paddle to go again. So everybody's saying that my voice is a little bit different today, guys. That's just because I have a bit of a cold. So don't worry too much about my voice. It's still me. So let's have a look at creating a backdrop. So if we click on our stage, we can go into the Backdrops tab. And here you can see a couple of different backgrounds that I've created. So the first one I had was lava. So I just drew a red rectangle here. And if you want to see that red rectangle being drawn again, you can click on this. Change the color to, maybe we'll choose a darker red just to show the difference. And we have a rectangle selected. Then you can just draw the red rectangle on top. And you can make it to whatever size you want. So if you want it to be halfway up the page or down a little bit towards the bottom, you can do that. If you want to change the sky as well, you can also, let's just duplicate this one. So now we have an exact copy of it. If you want to change the sky to a gradient, you can use some of the other features as well of the paint bucket. And you can change it to a nice light blue sky by clicking here. And I'm sure some of you guys already know how to do that. And if you're asking how many backdrops can you make, well, you can make as many as you'd like. I've seen some projects that have over 400 backdrops in it, and they change it as they go along in the project. So what does the duplicate do, James? It actually duplicates what you have in the backdrop. So it makes an exact copy of what we have up here. So if I do it for my backdrop here, I can duplicate it. And we have another copy down here. So if I make any changes, let's say we just decide to draw scribbles on the page, we can still go back and use the one that doesn't have the scribbles. And if we don't like the scribbles on the page, if we made the mistake, we could use the arrow keys up here to hopefully undo it. There it is now. And so guys, if you want to add your own slingshot like there is in the actual Angry Birds game, you can add it as a sprite, or you can add it straight into the background by using the rectangles, or you can use the paintbrush as well. And if you make it really small to start with, then you can add it in and just zoom it up bigger later on. Is my voice still coming in a little bit strange for most people? Just type 1 if it is, because it just might be an audio issue on our own end, or if it's not. Okay, it seems like a lot of people are still having a bit of trouble with the audio. Let me just see if I can fix it up here. And we'll just do a quick sound check again. So 1 if you can hear me, and 0 if you cannot hear me. Okay, so lots of 1s coming in, so we'll have to just move on for that. If you are having trouble with the audio, maybe try changing the settings on the computer, or maybe just lowering the volume a little bit. So now that we know how to create a backdrop, we can use the one I have here. We need to start creating the sprites. But before we start creating the sprites, I want to talk to you guys about the blocks in Scratch. So the blocks all contain instructions, which is what we learned about in the last lesson. Some of the blocks look a little bit different, like for instance we have our repeat 10 and our move block. And inside these blocks we have code. And that's what the code is used on the computer to tell the sprites what to do. So in this example we have a for loop that tells the sprite to move 10 steps 10 times. And that's what it would look like if we were coding it properly. But because we can drag and drop the blocks, it's a lot easier to understand, and it'll allow us to actually work a lot faster because we're not worried about how to type out all of this stuff and make sure that it's working properly. And we can just simply drag and drop the blocks until it does exactly what we want it to do. If you are having trouble with the Scratch Studio, guys, we'll talk about it again at the end of today's lesson in the Q&A session. So don't worry too much about it. I'm going to come up with a new system for sending me on your project as well. So the reason that we use the blocks in Scratch, guys, is because we want to instruct the sprites what we want them to do. And that's exactly what we did in the last lesson. We told the cat sprite to follow the mouse. We also created a new project to say what our favorite game was or why kids should play games. And we told the sprites what to say on the screen. So today we're going to look at making Angry Pong, is what I call it. It's the same as Pong is, which is just a ball and a paddle jumping up and down on the screen. But we're going to use an Angry Bird instead of the ball. So let's have a look at some of the common instructions that we can use on a computer. A command tells the computer to do one thing. So like in the last lesson, we told the sprites to say hello, or tell them to say games are really good. We can also use blocks like the wait block to make the program wait for 1 second, which I'm sure a lot of you have done. And we have the move 10 steps as well. So these are all different types of instructions, and they're called commands. As you can see, they're all color-coded because we have the say block will affect how the sprite looks because it's able to say a text box on the screen. The yellow block is a control block because it tells the code to stop and wait for just 1 second or maybe 10 seconds. And the move block is all about motion as well. So we have loads of different colors for each different type of block in Scratch. Now sometimes in Scratch you do need to make a decision, and computers aren't exactly great at making decisions all by themselves. We can tell the computer is X bigger than Y, and if it is, the computer can say yes. We can also use another type of instruction called a loop, and we can tell the computer to jump on 1 foot 4 times, and it can do exactly that. So let's have a look at making a decision. So computers only make yes-no decisions. That means that if we ask the question, how is the weather? The computer is really not sure how to answer that because it's not a yes or a no question. So it doesn't know how to make that decision itself. We can use the if blocks in Scratch to say a different question, maybe rephrase it so that it is a yes-no answer. So else is used when we want to use the opposite for the answer. So let's have a look at what the question should be. So if we say, if there is rain, stay inside, and then else, if there is no rain, then we can go outside. And the computer is able to say, no, I'm going outside now. And just on the point of it being weather, guys, it's a really lovely day out here today in Ireland, so I'm hoping you guys have all got great weather as well. But for the moment, let's have a look at repeating instructions. So when computers need to repeat an instruction, you can tell them to do it as many times as you want. So like we had with our example, hop on one foot for 4 times, we can just tell the computer to do it 4 times. And to do loops in Scratch, there's lots of different blocks you can use. If you wanted to do something forever, you can use the forever block. If you wanted to do it 10 times, use the repeat block. And if you want to do a repeat until block, you can say, let's keep doing the same amount of code until something else happens, and then it can move on. This is known as an iterative process, and that's what you call it when you want to tell your friends that you're really smart and you know what an iterative process is, because all it really is using a loop in your code. So let's have a look at some of the key points of what we just learned there. If I told you guys, what are these blocks called? Maybe you'd be able to type it into the chat box and tell me right now. So these are all called commands. And that's exactly right. Looks like everybody has the right idea behind it. They are commands. If I said, what are these blocks? Would everybody be able to know what we would call these blocks in programming? So they're called statements, but what we know them as is decisions. And yes and no answers. So that's exactly what we call them. We'll call them decisions in code. And if you want to create a decision in the code, in Scratch we can also use these blue blocks. These are called sensing blocks because they can sense if the sprite is touching another sprite or if it's touching the edge. We can sense if the key on the keyboard is pressed, and we can also sense if one color is touching another color. And we'll have a look at using some of them decisions in today's lesson. And then lastly, and I'm sure you're all going to get this one, if I said, what were these blocks? Would you all be able to understand what they were? And of course, everybody is typing in loops. So that's exactly right. And iteratives as well, Claire. Brilliant answer. So everybody seems to have a great understanding of what's going on. Maybe we'll just take a quick moment to try out a poll and see if everybody knows what types of instructions are. So if I launch this one, will you guys be able to tell me what type of instruction is the move 10 steps block? And just type it in to, or type your answer into the poll there. We've got about 50% of everybody has voted already, so I'll give you maybe 2 more seconds to answer. So 1, 2, and we're going to close the poll now. So 86% of you guys figured out that it was a command. And lots of people are typing into the chat box to say, I meant to say decision there. But decision wouldn't be the correct answer. It's command. So let's have a look at another one. If we said, what type of instruction lets us move 10 steps 10 times? Which block will we be using then? So if we wanted to use the same move 10 steps command 10 times, we could use what block, what kind of thing would we use in Scratch to do it? Well, 75% of you guys have got the right answer here. So I'm going to just wait for another few seconds just to make sure you all have the right idea. And it seems as though a few people have put in for command, but it's actually a loop. So a few people typing in saying they meant to say loop, and that's absolutely fine. It's just going to go on your permanent record that you got the wrong answer. I'm just kidding. I'm just kidding. And then finally, and I'm sure nobody's going to have any trouble with this last one here. If we said we wanted to move 10 steps, if the right arrow key was pressed, which one would we be using then? So we only want to move 10 steps if a key has been pressed. And already 97% of you guys have got the right answer. So I'll just wait for a few more seconds. A few people are saying command again, but don't worry about it. It's not the move 10 steps block. It's what we would do if we wanted to press the right arrow key. And the polls are coming in now with 75% of people have voted. So we're just going to say it was 93% had the right answer there. Decision. So that's great, everybody. You seem to all understand exactly what we've been doing up until now. With that done, there's really nothing left for us to do but except to start making Angry Pong. So the first thing we need to do is create the two sprites. As you've seen in the project at the start of the lesson, I have one sprite for my paddle and I have an Angry Bird to play as the ball. So the first thing we need to do is instruct the paddle how to move. And then we need to instruct the Angry Bird how to move afterwards. So let's have a look at what we're going to use to move the paddle. And if you've already understand how you're going to move the paddle, let's have a look at some of the other ways you can move the paddle as well. For instance, if we look at this code, and we're using two sets of loops here, we have a forever loop that says repeat the change x by 10 block 40 times. So that means that we're going to move 10 steps all the way across the screen. And then once we finish that, we're going to change x by minus 10, which means we're going to go in the left direction. So that means that our paddle will be moving forwards and backwards, and because it's inside the forever loop, it'll do that forever. Which is great if you wanted the paddle to always be blocking. But maybe Angry Bird will go to one side of the screen when the paddle is on the other side of the screen, and you won't be able to control it. So it's not the best method to use. The next one we have is a forever loop, again, and we can say, tell the paddle to point towards the mouse pointer and then move 10 steps in that direction. So that means that the paddle will always hover underneath the mouse pointer. And then you can use the mouse pointer and drag it back and forth across the screen to block the Angry Bird. Unfortunately, you can move the paddle up to meet the Angry Bird at the top of the screen, so it gets a little bit messy. But if you'd like to program your game that way, you can absolutely do that. The way I think is the best way is if we use both a loop and a decision together to tell the command when to go. If we use the right arrow key, we can change x by 10. And if we use the left arrow key, we can change x by minus 10. So guys, with that in mind, there's 3 new ways to program our paddle. What I'm going to do now is ask you which one should we use. So just take a quick moment and figure out which one should we use. Should we use the automated step for 1? Should we use using the mouse pointer for number 2? Or should we use number 3, the right arrow and the left arrow keys to move the paddle? And Olivia thinks I sound a bit like a robot. Well, I'll have to try to sound a little bit less like a robot for the rest of the lesson. And Zayad, if you could stop spamming the chat box, it's just that I can't see anybody else's questions and all you're typing is the number 3. So just hang back for a moment. Okay, and we can close the poll there because we have an outstanding amount of everybody saying 76% of you said let's do number 3. And that's what I'm going to do right now. So here I have, guys, in my starter project for Angry Pong, which I'll send to you guys at the end of the lesson, my blank Angry Bird and my blank paddle. The first thing I'm going to need to do is grab when my green flag is clicked. And that event will say, when we click the green flag at the top of the project, we can start to run the code we're going to use. So let's think about the commands we're going to use first of all. We know we're going to change x by 10, and we know we're going to change x by minus 10 to move left. Next we need to get the decision, and you say if, we'll go into our sensing block and say the key right arrow is pressed, then we can change x by 10. And see how the if block stretches to fit in the right arrow key. It's because it's the right shape, so it doesn't matter if it's too big to go in there, it will always stretch to fit in. And if we need to duplicate the code, we can always duplicate it here, put it underneath, and then get rid of the change x block by dropping it back into the block palette where it gets deleted. Now we can use our change x by minus 10, and don't forget to change the right arrow to the left arrow. If we run the project like this, and we press play, when I press my arrow keys, nothing happens. And that's because the computer moves so fast that it checked to see if we were pressing the right arrow key and if we were pressing the left arrow key, and then the game finished. There was no more code to write. So that's why we use our forever loop to always check and just keep going round and round in circles to check if the player is touching the right arrow key and the left arrow key. So if I do it now, I can see my paddle moving across the screen. And that's all the functionality I need for my paddle. So let's just take a couple of questions that are coming into the chat box now. How do you resize a sprite? Well, Graham, to resize a sprite, as some of you guys were pointing out in the last lesson, you can use the grow button to make it grow really big, and you can use the shrink button to make it really small as well. And how do you erase what you wrote in the script, Ahmed? If you want to erase it, let's just make a copy of this code. I'm going to duplicate it and say I don't want this code here. So you just drag it into the block palette and let go, and that's it gone. Where did I get the paddle and the Angry Bird from? Ashk, well, I made it myself, Ashk. So if you check out the first lesson, you can see how we learned how to draw sprites. In this example, I just drew a purple rectangle. And for the Angry Bird, I just copied it over bit by bit, going over each square, and then I made it really, really big at the end. If you want to get what you erased, and you made a mistake by erasing it in the first place, I think you can go into the edit and undelete the block. Wow! Brings it back way bigger than it's supposed to be. And there it is again. So now we can move on to programming our Angry Bird. What we need to do is add the following. First thing we need to do is add the movement. So we need to tell the Angry Bird to move up and down along the screen. And it's really simple to do. We're going to say move 5 steps, and if it's sitting on the edge, bounce. So when we touch the top of the screen, it'll bounce back down into the bottom of the screen. And that's why we use a forever loop, because that's all he's ever going to do, is just bounce off the screen and come back down. So we can add our when our green flag is clicked, we can say forever, and we can use our 2 motion blocks. One to say that if we're on the edge of the screen, then we can bounce, and the other one to say move. We'll change it to 5 steps because 10 might be a little bit too fast, but if you want to make it a really fast game of Pong, you can do 10 steps or 15 steps or maybe just 7 steps. If you're worried that you might not be able to do an Angry Bird the same way I've done, guys, I'm going to send you on the starter project at the end of the lesson, so you'll have access to the Angry Bird yourselves, or if you want to make your own sprites and you don't want to use an Angry Bird at all, you can make your own. So if you want to make a golf ball or anything like that, you can. Next we need to check what happens when the game is over. So we can add another when green flag is clicked block. We can tell the Angry Bird to go to the middle of the page and tell it to turn 15 degrees, or as Zayad is saying, we can turn 45 degrees. Then we can say wait until we're touching the color, which is the color of the bottom of the screen. So we have, I think we have 2 colors in our example. Do we have green and brown? So you can say when we're touching green or when we're touching brown. So in this example I said when we're touching brown. Then what we do is we stop the game altogether. So I'll grab my when my green flag is clicked. I'll say let's start the Angry Bird in the middle of the screen. So I can use my go to block. And I can type in 0 and 0. Now all I can say is turn 15 degrees at the start, or maybe we'll do 45 for today's lesson, just because it was in the chat box. And now we can use a wait until block. So just like the wait 1 second block, we have a wait until something happens block, and we can use our sensing tab to say if the Angry Bird is touching the color brown, and you can change the color by clicking on the color and hovering the mouse over whichever color you'd like. I want to make sure it's touching this color here, so I'm going to touch that one there. Then we can go into the control block and one more time grab our stop all block and tell the game to be over when we do it. So now if we click the green flag, we can see that the game is over. And when he touches the edge, he bounces, which is everything we wanted him to do, except he doesn't do anything when he touches the paddle. So that's the next thing we're going to need to fix. What happens when we touch the paddle? Well, we're going to always be checking to make sure that we're touching the paddle, and if he is touching the paddle, we're going to tell the Angry Bird to point in the up direction, because we want it to stop facing downwards and start facing straight up. Then we're going to tell him to move 5 steps in that direction and pick a random degree to turn. So he'll either turn to the left or turn to the right. And that's how we're using operators as well. So let's grab the code that we need. We'll say when our green flag is clicked, forever check if we're touching the paddle, and you can grab your touching block here. Use the drop down arrow to check to see the paddle block, and now we can fill in the code we need. So first of all, we want to say point in the up direction. So we'll drag our point in the direction block in and change it from facing right to facing up. Then we can tell them to move 5 steps as well. And then we can tell them to turn in whichever direction we would prefer. So instead of turning 15 degrees, we can use an operator, use our random variable, and say between minus 30 and 30 degrees. And that's all the code we're going to need to make sure that the paddle is working. Let's just try it out now. The Angry Bird goes to the middle, bounces off the paddle, and bounces off the top of the wall as well. So now our Angry Bird is working. And let's have a look at some of the questions here. So you can put a broadcast message in one at the end of the losing script and make the sprite saying that you lose as well. You put a green flag clicked and say when you receive the message show. Yeah, you can indeed say that. Did you type in paddle or was it there as an option, Ada? It was there as an option because I created the sprite paddle. And then if I wanted to do it here, you can see if I use my touching block, I can use the drop down arrow and the Angry Bird is an option on this one because the Angry Bird is another sprite. Where do you get the coordinates from Mohammed? Well, Mohammed, the stage is made up of coordinates. So if we take a look at the paddle for the Angry Bird for just one moment. He is at x is equal to 50 and y is equal to minus 6. If I move him closer to the middle of the stage, he's at minus 11 and 21. So that means that 0, 0 is at the center of the stage. I tried to get 0, 0 there. Let's have a look. If we use this block go to, that is the very center of the stage, which means if we move in a positive direction, x increases to a plus number. And if we move in a negative direction, it moves in a minus number. And it's the same for y as well. So if we move upwards, y moves into a positive. And if we use downwards, y turns into a negative. Emma's wondering if we can copy a pic off the internet for Angry Bird Sprite. Emma, you can indeed. If you prefer to do that, you absolutely can. And Billy's asking what about the score box to tell your score. So that's another thing you guys can do. You can go into your data tab, make a variable, and say for this sprite only, make a variable called score. And you can say when the green flag is clicked, set the score to 0. And when you're touching the paddle, change the score by 1. And if you don't want to see the big text there, you can just change it into a little orange box by clicking on it. Now when we run the green flag, you can see the score changes up and down as he touches the paddle. So let's have a look at some of the other questions that go back. Miriam, if you want to know how to make a golf scratch, you can absolutely use a golf ball instead of Angry Birds, but it'll still be golf pong. If you want to make a golf game, please just email me at the end of the lesson and I'll talk you through it if I can. Mason wants to know when we can replay the video. Well, Mason, it will be on the Show Academy website tomorrow afternoon. So that means in 24 hours, you'll be able to do it. Let's have another question now. How do you set the position of the paddle from Simon? Well, if you want to set the position of the paddle, you can add a block in to say go to somewhere. So you can use a go to block to tell them to go somewhere here. For me, I just put it wherever I wanted it by just dragging it. So you can leave it up really high. And you can make it avoid it. And then if he loses it and you miss him, the game is over. So now it's your turn, guys. I want you guys to create your own unique sprites, just like we did with the Angry Bird. Then start coding the instructions for them sprites. Don't forget to add the background as well. And maybe change it up a little as well, maybe make it do something extra that I didn't do in today's lesson.